Okay, I think I still should do the P-act and NY one. Yeah, let's do it. It won't take that much time. So let's start from a new cell. So it's going to be test no P-act NY. Let's start from the layout view. And I still remember that the parameters for these guys 80 1080 1030 1068 5050. All right, let's do it. So now we have P-act, right? So is that P-act? Yeah, P-act and NY. So P-act NY is here, and NY we have 1080. We have how many 1080s? I think 2. And another one, which is 1068, and another 2, which is 1030. Yeah, directly just copy that one. All right, so that's all these bars. And apparently this one is horizontal. It's horizontal as well. And this is 50-50. And let's make it at the origin. All right, and this guy, this guy, this guy, this guy, and this guy. Let's see how quickly we can do it. I hope we can get it done as soon as possible. I don't want to take that much time to just work on the diode, right? Let's 60A. Zoom in, make sure it's horizontal. All right, so it is horizontal, is it? Let's make sure X position, since the entire length is 60A, so we need a 34 actually. Right? No, 34. You need X to be 0 and Y doesn't matter. So as long as X is 0, which means it's in the middle of this origin. And then this guy, I'm going to move it to make it overlap. So look at these two nodes. Overlap, perfect. Same here. No. Overlap, boom. Right? I think it's too close, is it? Yeah, this is too close. No, I don't want that. Probably this. This looks good. And this guy, I need it to overlap with this one. This. All right, looks good. So this one, this time we get it done pretty quickly. Right click, right click, right click, connect all of them, and then get a node. So what's the width over here? Like 10? Yeah, let's make 10 as well. So x-axis should be 10. Boom. Yeah, it's not working. Let's rechange it. So we have a node which is 10. So it works in either way, doesn't matter. And so pick up the node and do a P-act. Did I use capital uppercase or lowercase? Uppercase, which is weird. I want to make it consistent. Let's make it consistent though. No, yeah, let's do that. Cancel. Act. Pwell. unact Pwell. Do we really need to separate it? I don't think so. Let's just do that. Unact and Pwell. And same here. So let's do Pact and make it to be 10. And this guy is unwell. And the same thing, change the size to be 10. All right, F5. And now let's right click and make a new schematic out of it. So it's going to be test, Pact, unwell. All right, and grab a delt and put it here and make a node, and this is apparently it's going to be unwell. This is unwell. This is Pact L. So schematic LVS match. Great. So we're done for the delt. What's the next? Let's take a look. So next should be the pad, I think. Should be this guy. As you can see, what I did over here is I make this one, and I grab this one to here, and I make a metal. So what's the size of the metal? 84. Okay, doesn't matter. It's not a big deal. And we want to make a pad. So you need to be clear about that. So the pad, if you look at the chip, I have a. If you go to the chip, you can see these are the pads, right? So the pads, and these are the dials. So that's a pad, and the purple color is a metal 2, right? So the pad need to be on the very top, layer, because it's being used to connect to the bonding wires. Did I save this one? I think I did. Toss this one. So let's draw it so we are clear what's going on over there. If you look at the, so for example, here's a chip, right? Here's a chip, and that's a gate, right? So that's poly 1, that's polysilicon, that's poly 1, and there's another poly layer actually. So you get a poly 2 layer as well. I think I should delete everything. Just want to make it. Since, for example, we didn't pattern anything on the chip, right? So the first layer is oxide, right? And then poly, no, why should I pick up that? Poly. And now we can probably use a color to let you know what is that color being represented, what is that layer being represented electrical VLSI. And after, so that's poly, that's ox, and this is another ox. And then poly 2, and I think poly 2 was a color for poly 2. I think it's something around this. Something around this. All right, and then ox and metal 1. And ox, right? Metal 2. And metal 3. So after metal 3, for example, I don't have space over here. So for example, metal 3 is the very top metal layer, right? And metal 3, you need an opening on the chip. If you do not have an opening here, it's going to be another layer on the top of metal 3. It's called passivation layer. It's a silicon dioxide, actually. So it's gonna be this. If you do not have opening, how can you connect this one outside to the chip, right? To the pins of the chip. So actually you need an opening. So you need an opening here. So you can connect this bonding wire to the chip. And you have so many other layers on at the bottom, and that's your, like, for example, N plus, right? Blah 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 blah. So that's a P sub. So just want to let you know that you need a pad on the very top layer. So for example, this is the pad, metal 3. This is a cross-sectional view, keep in mind. So for example, that's a pad, right? Metal 3 pad. And here's a wire. That's a passivation layer, but has a hole on that. So we can solder a wire, a bonding wire, super thin. That's a super thin bonding wire. Solder the wire to this pad, to this metal 3 pad, and connect to whatever in the circuit. Okay, so that's why we are having these paths. So these passivation layers are actually the openings on the top of the metal 3 layer, and we do need that one to make our metal 3 being connected to the outside world. So now, since the next step should be the pad, right? So we're making a pad. So instead of naming this, I'm going to create a new cell, and I'll name it test and pad analog. And let's start from the layout. So layout, I need so let's check what's the size of this guy. So 250, 250. And now let's come over here and pick up. So what are these ones? So these 3 layers are, you can imagine that because the purple color is metal 2, so we need a metal 2 to metal 3 connector, through hole, and metal 3. Yeah, now let's take a look. So what is this? This is a passivation layer, passivation node, and this is a metal 2 to metal 3 contact. And I think there's another one. There should be a metal 3 layer as well, but I couldn't. There should be a metal 3 layer as well. No, so this one, that's the metal 1 to metal 2 layer. Metal 1 to metal 2 contact, and this is metal 2 to metal 3 contact, and a passivation layer. So what happened over here is metal 3 is the very top metal, and we have 2 through holes from metal 1 to metal 2 and metal 2 to metal 3, right? So which means it already drill a hole from the metal 2 layer to the metal 3 layer. So which means there's a hole over here already, because that's oxide, right? And that's metal 2. So which means you already have a through hole here. And that through hole is the same size as whatever the metal 2 is. So actually you do not, if I only have a metal 2 to metal 3 contact, which means it's going to be a hole here, but there's no metal 3 layer being really laid out over here. The reason is you can imagine that metal 2 to metal 3, you have all these holes. And if you have a metal 3 layer on the top, I don't think it's going to stay there because it's the same size, and these holes, there will be a lot of holes, and the metal 3 won't stay there. So that's what's happening. But let me check if this is accurate. I remember there should be a metal three layer over there on the pad. I didn't see that. So let me pause a little bit and come back and check real quick and come back. Okay. Okay. So the conclusion is you do not need a metal three layer. So you just need a metal two contact, metal two to metal three contact, and a passivation layer, and that's it. So it's gonna work. So let's come back here and see what I had over here. I had three layers, including the metal one layer, but I am not actually using that node at all. So I don't think I need it because all these wires being connected to the pad is a metal two only. And let's make that passivation and the metal two to metal three connector. So this guy should be at 0, 0, and it's 250 and 250. All right. And now we need a pure passivation node, which is this guy. So 250, 250, 0, 0 as well. 250, 250. And we need a metal tool node here and put it here at the middle. And we need to define the width of that. So I need to check here what is the width and length. So the width is 30, and I don't know length, but I think it's fine. Let's just make a 30. So this guy, and connect that one out to here, and do 30. And you need these two diodes. So the first one is N act. So N is, you want to select this one and click visible. You can see this. So we want to N act, so which means this diode and compared to this diode, what's the difference? So which one, where do you want to connect this to? So that's N act, P act. So it seems like it's something like this, right? I think I saved it already, did I? Yes, I did. So let's start a new page. N act, P act. Remember that if we have an input for the chip and we want to protect the chip by using these two ESD diodes, VDD, and here ground. So because this is being shorted to this terminal, it's like our pad, right? So that's a pad. So that's a pad and has a metal two wire comes out from it, right? And then you have a diode like this, another diode like this, and you have another pin here to connect to whatever inside the chip. And so this one should be what? Because this is, if we connect this to VDD, this pin here, we connect it to VDD, a VDD metal three layer here, like this. So because this is metal one, and you connect to another one, and this one has a direct connect to metal three, and this is metal one, metal two connector, and that's metal two, and that's metal one. Okay, and this is metal three. So the yellow color, right, is metal three. So nothing is being shorted because this is the metal three is on the very top layer. And whatever this node is, it can be anything. It can be a VDD, can be ground, can be IO pin, right? We're not differentiating the different paths. But, if you want to make it professional, it should be different because you need a driving circuit for the digital circuit to make it fast, right? So if this is VDD, the inner layer is VDD, and the outer layer is ground. So this is being connected to ground, and this should be a metal 1 to metal 2 connector, and this is metal 2, right? And this is metal 1. And then you need another connector, that's metal 2 to metal 3 connector, and it's going to drill a hole from metal 2 to metal 3, so you can draw a layer. And if we make into yellow color, so this one will connect to the yellow color metal 3 over here, right? Same to this guy, it's a metal 2 to metal 3 connector. It's going to be shorted to this metal 3. So this will be a VDD, this will be a VDD metal 3, this will be a ground metal 3, and surround all the chip. Okay, so this is a strategy for making that happen. And because this is VDD, you can imagine this VDD the same as this VDD. So this node here should be what? Should be the Pwell. So you need an N act, and no, you need an N. So that's a P act and N well. So this should be a P act and N well, right? And this should be an N act. Okay, so now you know which one should be placed at where. And now let's see if this is right. Let's come back and take a look. What I have pad analog. So you can see that is P act, right? And this is N act. So the P act should be on the top. The P act node should diode should be on the top. N act diode should be at the bottom. It's the same as what we just get a conclusion. So P act, N act. So now let's just place the two diodes over here. So P act should be on the top. N act should be at the bottom. Okay. Because this is metal 1, right? Metal 1 to metal 2, you can directly connect them together because they, but you don't want to make these two guys too close because these ones are the N plus to metal 1 contact. So this should have a little distance. So you want to extend this a little bit first and then connect it to the metal 2. So you can see directly, it's going to directly create a metal 1 to metal 2 through hole here, contact. You don't need to place this guy over here. No, this guy, which is metal 1 to metal 2 through hole. It's going to drill a hole to the top to connect to metal 2. It's going to create this guy directly for you. Same to this one. So left click to select it and then extend it and then connect to the metal 2 layer. So apparently this is too long. So I'm thinking to make it shorter. I don't know if I should do that, but I think maybe it's a little bit too long. So let's make it shorter. See if I can do that. Seems like I cannot. So you can delete it. And then extend it to somewhere which is shorter. All right, save it and F5, 2 errors. What are they? Let's see, what is the error here? Metal 2 overlays node metal 2 to metal 3 contact. Oh, so I actually didn't connect them together, which is interesting. I think I did it. See, I didn't connect it to this guy. Interesting. So now let's redo it. So let's place it at 0, 0, and I'm gonna select this node, and boom, I'm pretty sure it's being connected right now. If I drag it, you can see it's being dragged away. What did I do? All right. Okay, so it's ready. And place this guy at 0 as well. And now I'll do F5, so it's DRC clean now. So that's the first step. And the second step, you need a metal 3 layer to connect this pin out to the, because later on it's going to be a ring of all these paths being connected one by one. So you need to connect from left to right and right to left. So let's make this. But before we do that, I want to check the size. So what was the size I used over here? That's like 300 something by 84. 320 by 84. Let's just use that value. So that will be no, not here. Sorry. Should be there. Here, metal 3. Pick up a note, and no, you want to do a C. Just press C, change it. So it's a metal pin. You need a metal note actually, and change it. And Control I. You want to change the X and Y size. I remember it is 84 by 320, I think. Let's try it. And now Control J. It's too long, I think. Was that this long? 320, 84. Yeah. Why it looks so big over here? It's fine. This is a little bit too long. The reason we do not want this to be too long is, keep in mind, you want a 1.5 by 1.5 millimeter, which is about yeah, let's measure it. I don't want to make any mistake over here at the very early stage. So this is actually 400, right? And what about this? This is 80 something, all right? So because the reason why it doesn't match is because it extended on the two sides, but it still looks too big. 250. Let's see, 250. Oh, it's 600 right now. So we need 400, and for Y we need 84, I think. All right, so now it's better, a lot better. And we hope the position, X position, to be 0. See if it's 0. It's 0 right now. And we just want this one to cover this dot. They're not connecting to each other, so it doesn't matter if it just make it looks better. And we need another one here. I hope the X is 0 as well. All right, and so now we want to make a connect from here. You want to click Control and select it, and connect it to a metal. Since this is the metal 1 node, right? So because this is the N-well has all these metal 1 nodes, metal 1 through holes over there. So the first thing you need to because if you don't do anything, you can see that I just connect here to here. It's going to be a no. See, it's a metal 1. So it's coming from here is the metal 1. So I need a metal 1 to metal 2 connector, and then metal 2 to metal 3 connector, and then connect to this yellow metal 3 layer. Let's find out the dimension for that one. I think it is like 84. So let's find the 84 node, metal 1 to metal 2. So let's make the axis to be 10, and this should be 84. And we put it here, right? So that's the first step. And the second step is this guy. And this guy need to be the same thing, 10 and 84. All right, so put it here for the final contact. So we want to do this, pick it up, right click. So that's metal 1 to metal 2, and we want to make this one longer, so which is 84, and do not let it extend on either end, so it looks better. Same here, right? Pick it up, and then metal 2 to here. All right, and we want to do the same thing here, but we do not need a metal 1 to metal 3 connect, because this is just directly going to, if you have another pad over here on the side, on the other side, you just need a metal 3 to metal 3 connector, right? So you can directly just do this, just use this one. I will just copy and paste that guy, so that make sure they're consistent. And keep using the same part. So how can you connect this one to metal 3? So the way to do that is just click it, and pick up a metal 3 and right click. Okay, and check really quick. Get 2 errors. What are they? Metal 2 to metal 3 contact overlaps. Metal 3 node. Which one? Oh, because I didn't connect this guy to metal 3, right? So now let's do it again. It's clean. DRC clean right now. So just do the same thing to this one. I will copy. If you find out, if you do not press Control, it's hard to select this guy, right? See, I cannot select this metal 1 to metal 2 connector. You have to press Control at the same time to do the job. So let's place it here and place this here, and the same thing here. It doesn't have to be accurate, right? So make sure it's being select, connect. All right, select, connect, change the width, 84, and Control I, neither end, right? Connect, metal 3, connect, F5, clean. All right, it's pretty much you're done for this one. So now we need to name it. So you want to make sure you are picking up a metal node connector, and Control E. So you want to export this as analog. It's just a name. You need a port for this one. And Control I, so make this one to be 100. And you need this one to be, I will just export all these nodes, right? So for example, this is VDD 1. This is on the left side. I just name it VDD 1 because there will be a VDD 2 somewhere else. And I make it 10. Let's make it 20. Looks better. And this one, Control E, VDD 2. Control I, 20. And Control click, Control E, ground 1. And Control click, Control I, 20. Control click, pick it up, ground 2. And Control click, Control I, 20. All right, F5, clean. L, we don't have a L, we don't have a schematic. So now let's create, no, we are missing another port here. So pick up this one, Control E, You want to name it analog 1. So this is being should be connected to the whatever input inside the chip. Control I, 20. All right, so the pad is done. There's another thing we haven't done yet, which should be the while. So we hope this one is being fabricated in, because this is a P-act and unwell. So P-act should be fabricated in unwell. So we hope everything here is unwell, but not just this part. We need a larger unwell. So we need a unwell node. And I'm gonna double click. I forgot the size. What's the size of it? So this is 400 by 84. Let's make it a little bit larger. So what about 500 by 100? All right, and place it on the top and make it in the middle. So that's the unwell. And the same thing, you need a Pwell. No, Pwell, because you want everything here to be in the Pwell, because unact should be directly fabricated in the P sub. So this is what you usually do, right? 580. We use 100, I think. That's what we use, and make it at 0. No, it's not that one. Yeah, not a Pwell. Sorry, I was wrong. So it should be a Pwell node, right? Pwell node, not a Pwell. You need a Pwell node like this, and it should be 500 by 100, and should be 0 for X. And now just move it down. Yeah, it's better to use mouse. It's faster to cover it. All right. No, X should be accurate. So this is accurate, but just adjusting Y. Never mind. F5 is clean. Again, we need to make a schematic out of it and icon as well. So now let's check, what did I use? What did I do? The schematic is just 4 pins. It's pretty simple. And icon, we just make a square out of it. So let's do it, and we will stop this video since it's too long. And let's right click and create a new cell. This is going to be a schematic, and let's call it test pad analog pin. And there will be 4 pins. 1, 2, 3, 4. And Control J and make X to be 0. So it's in the middle. And let's see, what did I do over here? All right, got it. So now let's come back here. Control J, Control J. Yeah, I think they're too far away from each other. Control J, like this, here. And now let's make the connect. So what are they? If you look at the layout, how many pins do we have? 1, 2, 3, 4, 5, 6. So actually 6 pins. So we need another 2 of them. Right? So that's a VDD line, right? That's a metal tray. That's a ground line. And that's a pin. This is a pad going to the L side. So that's analog. That's analog 1. That's VDD1. That's VDD2. That's ground 1. That's ground 2. So now let's make it. Here, Control E, it's analog. They have to be the same spell, right? VDD1, VDD2, and ground 1, ground 2. and analog 1. All right, LVS matches. Okay, F5, no problem. So now we need an icon. See what did I do for the icon? So the icon need to be a specific size, 25 by 25. Now let's make it. So I double click here and go to view, make an icon view, and go to icon. And you want to change this guy to 25 by 25 and OK. And this guy should be here, analog should be on the top. No, where? Pick up this one, shift click to deselect that one, Ctrl J, Ctrl J, Ctrl J, and make it here. Yeah, it looks a little bit different from mine, but I mean, it's gonna work. Same as these ones. So now let's take them out first. Shift click, deselect the square. It's not control click, it's a bit different. And let's, yeah, how to separate them. It's tricky. All right, great, works pretty well. Test pad. Oh, that's a name for this guy. Yeah, I hope this guy is in the middle, right? So hope this one to be in the middle. And analog 1, Control J, wait. Analog 1, Control J. And VDD 1. Here. VDD 2 here. Ground 1. Ground 2. Save. I don't know why this is so long. I don't like that. But I'm losing one node. No, it's not being lost. Actually, it's here. We just need a wire to connect to here probably. Now let's pick up a wire. I don't think it's artwork. It should be Moses, and shouldn't be a layout. Why is it a layout? Schematic. All right. So this one. Okay. Analog. Right. Comes back. All right. So this is the icon. And now let's go back here. See if we can still pass that LVS and DRC. So it's fine now, right? Control S to save it. So we get a one pad, and in the next video, I'm going to combine all these pads and to make a pad frame and place our chips into the pad frame. All right, see you in the next video.